Hello, this is Mr. Stansbury. I'm going to take you through the notes on graphs of functions. At the end of this, you should be able to say, I can find Axyz Intercepts, turning points, asymptotes, domain and range, and sketch a graph of various unfamiliar functions. Okay, so there's a lot of important stuff here on these functions. Key features of a graph. Axyz intercepts. So those are where the graph cuts the x and the y-axis. So here's our 1, 2, 3 x-intercepts, and here's our 1 y-intercept. And if it's a function, you can only ever have one y-intercept. You can't run into two. Okay. Turning points. These are local and global minimums and maximums. Okay. So first off, just minimum, maximum. So this here is a minimum, and this here is a maximum. And these are also what they call turning points, because as you're reading left to right, this is going down, 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 and this is where, at this point here, is where it turns from going down to going back up. And this is also a turning point where it stops going up and turns to start going back down. Okay? Local means that, like this here is a local minimum, because it's the lowest point in that graph in this area right here, but actually the graph has that's not the minimum ever on the graph, because there's lower points over here. And this is also a local maximum because this is the highest it gets in this general area, but over here it gets higher. So for example, this here would be a global maximum, and then this here would be a global minimum, because it never gets lower at any point on those graphs. So these are globals, global minimum, maximum, and then these are local minimum and maximums. Okay? Asymptotes are lines that the graph approaches but never actually reaches. So this right here would be considered the horizontal asymptote. So it gets really down really close to this line here, but it never actually gets to it. And this one here is a vertical asymptote. This graph here goes up and up and up and gets closer and closer to this line, but never actually touches it. Okay, so those are asymptotes. And then endpoints is the beginning or ending point. So this graph starts right here at 0 and goes forever and ever to the right. So that is an endpoint. Okay, let's take a look at all of this information here on an example. So example 6, consider the function, this negative blah, 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 blah. We're going to find the Axyz intercepts, turning points, asymptotes, find the domain and range, and then we're going to sketch the function showing any key features. Okay, so here's what we're going to want to do. We are going to want to put this thing into our graphing calculator. It's obviously, with all this information here, it's super important to get this right the first time. So I clear that out. This is negative, not subtract, so it's negative. And then this whole, it's the negative of this whole thing. So here's really what I'm going to do. Actually, this negative can go on the top, so let's just worry about that. So this 2x minus 10, they both have to be in the top. So the important thing on graphing is you can never have, well, for the most part, you can't have too many parentheses. So when in doubt, put some parentheses on there, right? So negative, we got 2x minus 10. So 2x minus 10. Close it, divide by, and now on the bottom we've got x squared minus 2x. Again, it's okay now. Actually, you have to now. If it's not the leading number here, leading term, then you have to put the subtract instead of the negative. So minus 2x minus 3, close that, and then this should be still in our normal, like zoom standard, but let's just double check. Zoom standard is 6, and that should give us hopefully a pretty good look at this graph here. Okay, so that's, it's a weird looking graph. Okay, but it's okay, we got this thing. We've got some time, and we'll go through and work through each one of these out. So Axyz intercepts, these are where it runs into the x and runs into the y, right? So here's probably the quickest way to do Axyz intercepts. Second trace, which is the calculate. Okay. First thing here is value. We're going to start with that because we're going to push enter on value, and it's going to say, hey, we want to know when x equals 0. That'll tell us what the y-intercept is, right? So I'm going to put in x equals 0, and that tells us that the y-intercept is negative 3.33. So y-intercept is negative 3.33, right? So 1, 2, 3, 4. So there's our y-intercept. I'm just doing this right now because it does say at the end, sketch the function showing all the key features. That's all these key features up here. Okay. Now we got to find the X-intercepts. So you do same thing, second calculate. And now we're going to find the next thing down is the zeros. So 0 is basically what it's going to do. It's going to look to see when the sign changes. And that's when it crosses through the x-axis. So here's our x is at negative 1.5 and our y is at 5.6. So here's what I'm going to do. I'm just going to kind of watch. I'm going to keep pushing the arrow to the left here. I'm going to watch my y value. As soon as that turns to negative, then I know that it's crossed through the x-axis, and we know that there's going to be a intercept there. I'm not even sure if there is one on here. In fact, it really looks like 0 is an asymptote, but that's okay because that comes up on part C here. Okay, so if we look farther and farther back out there, it's not looking like it's going to run into anything. So another way to double check, second calculate and put in a value. Let's put in, like, say x is, let's say negative 100. Let's see if it'll even do that for us. It's too big. Okay, let's try that again. Okay, clear graph, second calculate. Okay, so apparently this one's only letting us check to within the range that we're at. So anyway, we're noticing as we're getting farther and farther to the left, it's just getting closer and closer to 0, but it does not appear that it's going to cross through. So that means there's no x-intercept over here. And then also, look, that means that this is an asymptote right here. So this line right here, this horizontal line crosses through the y-axis, so that I know that that is going to be y equals 0, because right here, all along that line, the y value is 0. And so that's one of our asymptotes, y equals 0. Okay, so even though we went through and couldn't find one, that actually helped us out for something else. Let's zoom standard again to kind of get our graph centered back. Okay, and then now it does look like there is an x-intercept down here. So let's see if we can find that. Second calculate, and we're going to find the 0. So now we're going to go to the right here. Okay, so now look, here's our y is positive. So here's what we're going to do. It says left bound. So we want to get this thing to the left before it crosses through the axis. So I'm just going to push enter for right now. And then I'm going to push to the right here. I'm going to wait for this y. Look, the y is turned negative. So we know that it's crossed through here at some point. So now right bound, I'm going to push enter. And what it's going to do is it's going to look between these 2 points here, these 2 lines here. It's going to look to see when this graph has changed signs, which we know that it did because it was positive and now it's negative. So now it says guess, sure, guess, push enter, and it tells us that their x-intercept is at 5. So we also know there's one here at 1, 2, 3, 4, 5. There's an x-intercept. Okay, y-intercept's at negative 3.33, x-intercept at 5. Okay, find all the turning points. So that's when it stops going up and starts going down, or vice versa. This one here doesn't ever get down below, so that one's just going to keep going forever and ever. There's definitely a high point right there, so let's find that. So we'll do this second. That's a maximum. So we're going to calculate and find the maximum. So we go down here to number 4. Okay, so if I press this, I think there we go. So all we got to do is just get to the left before to the left of where we know the maximum has to be. We know that's not the maximum. It's going to be over here. So it says left bound, push enter. And then I'm going to move this thing over to the right until I know for sure that this thing is past the maximum. So it's, there. Now we know it's for sure past the maximum, but not over there, because up there it's going to give us some other weird value. Okay, so now there's a line here that we can't see because I actually put it right on the y-axis here. So it's going to check for the highest y value between these two lines. Guess. Yep. Push enter. And there's our turning point, 1.54 and negative 1.87. Okay, so we've got at 1.54 and negative 1. I can't remember. 87. So that is a local maximum, right? That's one of our turning points. And then on here, there's actually down here, I'm fairly certain it's actually gonna go down and then come back up eventually. Okay. When you get weird graphs like this, you're gonna have one that turns kind of slow and one that turns kind of fast. So see how this one's kind of got a little bit sharper of a turn. This one here is gonna have a maximum or a minimum on it. In this case, it's gonna be a minimum. So second calculate, go down to the minimum. And then we're going to move this thing over so we can see it. There it is. So that's definitely to the left of the minimum. And now I'm going to watch this. I'm going to watch the Y again. I'm going to watch for it. It's going to go low, 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 low. And then when it starts coming back up, then I know I've gotten past the minimum. So negative 0.9, negative 0.12, negative 0.13. And then look, now it's back to negative 0.12. And so forth and so on. So now I know that it's hit its minimum down there, because it was at one point down to negative 0.13, and now it's back up to negative 0.12. So now I'm going to push enter again, and it's going to find the lowest point in there, which is 8.46 and negative 0.13. So we've got, let's see, 8.46 negative 0.13. Is that what we said? Yep. Okay, and this is a local minimum. Okay, find the asymptotes. So we found this X asymptote for this one right here, although this actually crosses through it, so it's kind of a weird one there. But here we can figure out right here there's going to be some more asymptotes right here. So one way to do that is to find out what makes this equal to 0. So if you factor this bottom here, the denominator, x and x, the factors of 3 that have a difference of 2, 3 and 1 are the only factors of 3. That's going to be negative, and that's going to be positive. As negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So that means the other asymptotes, x cannot equal 3, because 3 minus 3 is 0, and we know we can't have a denominator of 0, so that's why that's the asymptote. And then the other one is going to be x equals negative 1 is the other asymptote. Okay? And then domain and range and sketch the function. I know we're running a little long here. Let's get this rolling here pretty quick. I think that domain and range is actually going to be a little bit easier after we sketch it. Okay, so we know that it's going like here. Let's do this. Let's put the asymptotes in there. We already did that one. And we've got negative 1 is another asymptote here. And then positive 3 is another asymptote. Okay. So we've got the asymptotes. We know that this one over here looks like, oops, sorry. We know this one over here looks like this. We know this one here comes up and then hits a maximum at 1.54 and negative 1.87. So that's about, say, right here. So we know that this one goes like this, right? And then this last one here comes down and it runs through that here and then comes back up. Okay, so it looks like they're actually, let's see, there could be, okay, well, we're not going to sweat that one for right now. Let's figure, we know that we've got this one and this one here, so that's going to be good enough for now. Okay, and then sketch the function showing key features. So here's all of our, here's our function with our key features. There's our maximum, there's our y-intercept, there's our x-intercept, and here's our minimum there. Okay, so domain, start, and stop. And then we'll put the X in there, and then we'll figure out the range here in a second. So this one starts here. It does not have a beginning, but it does stop. It's basically, it's going to stop before it gets to -1. So there's one part of it. Okay, and then this one here, it goes from, it has a second one where it starts at -1, and it goes all the way up until 1, 2, 3. So, and it doesn't hit either of those points. That's why we just have just the less than without the equal tos. And then we actually have one more, right? So it doesn't, let's see, it starts here at 3, but it goes on forever and ever to the right. It doesn't have an end. So here's our 3 pieces of domain. And then the range, and do the same thing. The y's here, the lowest it ever gets here is at 0. But it goes forever and ever up, so y's got to be greater than or equal to 0. And then for this one here, the y, so think of it as 3 different graphs. That's why we got 3 different domains and 3 different ranges, or 3 parts to it. That does not have a beginning. It's forever and ever low, but it does get up to a high point here of -1.87. -1.87, and so we know the y's got to be less than or equal to, because that's an actual maximum, 1.87. Okay, and then on this last one, it has a low point here, which is the local minimum of, starts at -0.13, and then it doesn't have a high point because this goes on forever and ever, right? So then y is less than, y is greater than -0.13, and that's our range for this here. That's a tricky one, okay? But I wanted to show you a tough one to make sure that you'd be able to get this all figured out. Okay? All right, if you have any further questions on this, please feel free to ask. Thanks.